All right, here we are on section 5.6. This is actually the last lesson or last section of this chapter. So I guess that's good. In one way, we're done this chapter. In another way, it means you're going to have a test pretty soon. So however you want to look at it. All right, let's talk about this. Inequalities in two triangles. We've talked about inequalities in one triangle. Now we're going to talk about two different triangles. I'll give you the name of this theorem that they give in the book, and it's called the hinge theorem. That sounds a little weird. But what you want to do is you want to think of something as being on a hinge and moving back and forth. And we'll talk about that here in a second. I used to call it, well, not just me, but other books that I've taught out of have called it the side angle side inequality theorem. All right, so side angle side inequality. I think the side angle side kind of describes it a little bit better. It makes it a little bit easier to understand. So that's why I threw that in here. Our book does not say side angle side inequality, but a lot of books that I've taught out of, several books that I've taught out of, call it this. But they call it the hinge theorem. And let's see what it actually says. All right, here it is. It says, now it's a little wordy, so we're going to take this a little bit at a time. We'll show you some pictures, okay, to help explain it a little bit better to you. It says, if two sides of a triangle are congruent to two sides of another triangle. There's our two triangles, okay? We got two sides congruent on one and another. And the included angle of the first, now here's what's different. Now we've talked about side angle side equality or side angle side, but we've had the two sides equal and the included angle equal. But look what it says. The included angle of the first is larger than, okay, oops, that's not good. Sorry about that. I messed something up when I touched those words. Let's try this again. All right, and let's go a different color. Sorry about that. It says, let's try it again. If two sides of a triangle are congruent to two sides of another triangle, and the included angle, that's the one that's in between. Remember that phrase? We've talked about that a little bit. Included angle of the first one is larger than the included angle of the second triangle, then the third side, okay, we're comparing the third side of the first triangle is larger than the third side of the second triangle. All right, he's thinking, what in the world are we talking about? That was pretty wordy. If I would have just read that all at once, I wouldn't understand it. So you got to take it a little bit at a time. So what we're going to do is we're going to try to draw our situation right here. It says if two sides of a triangle are congruent to two sides of another triangle. Let's draw that out. Okay, here's what we're going to start off with. If two sides of a triangle are congruent to two sides of another, I just copied and pasted this. So here's one side equal to one side, and here's another side equal to another side. But what does it say about the included angle? The angle right here in between those two sides. It says the included angle of the first one, this one right here, is larger than the included angle of the second one. Well, since I copied and pasted right now, they're equal to each other. But let's do that. Let's actually change this. We'll tap right there, and watch. We're going to make that included angle larger. So there we go. All right, let's scooch this down just a little bit so it doesn't run into the words. So what I have right here is I still have these two sides equal to these two sides, but I increased this angle. This angle right here is bigger than this little tiny angle right here. Now I put one arc. It doesn't mean they're equal. This is a big arc. This is a little arc. So we'll just say that, okay? So this arc is bigger than this one. So that's our situation. That's the if part. So it says if two sides of one triangle equal two sides of another, and then if the included angle of the first one is larger than the included angle of the second one, what can we now say, I should say, about the third side? What does it say? It says then the third side of the first one, this one right here, there's the third side of the first one, must be what? Must be longer than the third side of the second one. So if I made the third side of the second one right there. So if you take a look at this side right here and this side right here. This looks pretty much quite a bit bigger, doesn't it, than this side right here. And that's exactly what it's saying. That's why we call it the side angle side inequality. All right, it's the side angle side, but they also call it the hinge theorem. And again, the reason they call it the hinge theorem is this reason right here. See how this is on a hinge? All right, so the sides stay the same. It's just that angle is different. And as this increases, what happens to this red one right here? This red one right here increases. See how that even got larger? See, we increased that angle by a whole lot this time. So now this is a way bigger, and look at this side. This side is way bigger than it was here. So that's why they call it the hinge theorem. But I kind of like side angle side inequality. What's unequal? What's unequal are the angles, okay? One angle is larger than the other. The two sides stayed the same, but the included angle here is larger than the included angle here. And what does it do to our third side? It increases the length of the third side. So the side that's opposite the bigger angle on this one is going to be bigger than the side opposite the smaller angle, even though these two are exactly the same. Let's go to GeoGebra real quick and see how that works. Okay, I have two triangles right here. If you look at them, they are congruent to each other. Look, 6 and 6, 4 and 4. This is 4.6 and this is 4.6. They have the same angle. So they're congruent for all kinds of reasons. But what I want to do here is just kind of demonstrate what we were doing earlier. Watch this. If I take this corner right here and I'm going to increase that angle from 50 degrees, look what happens. I'm getting bigger and bigger and bigger and bigger. What's happening to that third side? Remember, it was 4.6, wasn't it? When this was 50 degrees. It was 4.6, but what I'm doing is I'm increasing that angle. Look down here at this angle. Okay, that angle is increasing as I'm moving this around. The 4 and the 6 didn't change, did they? This 6 and this 4 stayed exactly the same. So those lengths are the same. What's the only thing I'm changing? I'm changing the angle, which in turn does what to the opposite side? It increases this opposite side right here. So the bigger the angle gets, the bigger the side gets. Now I could even make this smaller. Watch, if I make that angle smaller, then that side gets smaller, okay, as you can see. So you're comparing two triangles as the 6 and the 4 stay the same, but as the angle increases, the side opposite that angle increases. And that's what it's telling you. It's kind of good to see visually and see the numbers actually change like that. Okay, here's another theorem, and it looks pretty much like the other one, except we've reversed things around a little bit. This is called the converse of the hinge theorem. All right, so we switch the if and the then around, but I'm not a big fan of that name right there. The hinge theorem's okay, but the converse of the hinge theorem, and that's okay as well, but this is what other books have called it that I've actually taught out of. Before this one, they call it side, side, side inequality. I'll just shorten it so it fits on here. Okay, the side, side, side inequality. Let's see why they call it the side, side, side inequality. Well, let's read it. It says if two sides of a triangle are congruent to two sides of another triangle, the other theorem started off exactly the same way. And the third side, remember the other one said and the included angle. This one says and the third side in the first one is longer than the third side in the second one. So that's what I did. See how I put the big old tick marks right here? That just kind of indicates to me that this side is bigger than this side right here. They don't do that in the book, but it kind of is a good visual to understand that this side is bigger than this one, okay? So let's see it again. And the third side in the first one right here is longer than the third side in the second one. So that one's longer than that one. Now, what does it say? What is our conclusion? Then the included angle measure of the first triangle, which would be this one right here, is greater than the included angle measure of the second one. Remember what this is saying. The first hinge theorem said if the angle is bigger, if this angle is bigger than this one, then this side is bigger than this side. The converse is just saying the opposite way. It's just saying, okay, if this side, if this opposite side is bigger than this opposite side, then the angles, or I should say this, if the third side is bigger than this third side right here, then the angle opposite the side is bigger than the angle opposite the little side. See, this is the big side, and this is the big angle. This is the, let's call it little. Okay, I called it that before. So this is the little side, and guess what this angle is? That's the little angle. All right, so the big angle is opposite the big side, or the big side is opposite the big angle. Either way, that kind of sums up the hinge theorem and the converse of the hinge theorem, or the side angle side inequality and the side 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 inequality. Let's go back to this again. It's the same exact situation, except it's just what you look at. So this time, don't look at the angle changing. Let's take a look at this. Let's say, let's see if I can get it back to the same. There we go. They're congruent right now. So watch what happens. As I increase this side, as this side gets bigger, watch, right there. As that side gets bigger, What's happening to my angle compared to what it was before? That's getting bigger. So that's side inequality, or the converse of the hinge theorem. As the side gets bigger, the angle gets bigger. It's pretty much the same kind of thing. It just depends on how you look at it. All right, so we've got the hinge theorem and the converse of the hinge theorem. Let's do an example and we'll be finished. Okay, here's an example, and they give you a couple triangles, and they give you some measurements, and they're going to ask you, the question says, compare the given measures. And so their given measures, they write down KL, I'm sorry, JK, said KL, and MQ. So they say, right, they write it up here, compare the given measures. Compare JK. I labeled this wrong. Hang on just a second. There we go. That's better. I messed this up. The L was here and the J was here. It should be like this. All right, so I'm going to compare JK and MQ. Well, look what I have. I've got an equal side right here. I've got an equal side right here. So those are my two equal sides. And I have, look, I got a big angle here and a little angle here. They're not equal to each other. This is bigger than this one. So what our theorem says, our hinge theorem says this. This is side angle side inequality. So I've got two equal sides and an unequal angle. And so what we're going to do is we're going to look across from it. So if this is 72 and this is 61, then KJ is opposite the 72, the bigger angle, and QM or MQ is opposite the smaller angle. So this has to be the bigger side, and this has to be the smaller or the little side. I guess smaller would probably be a better way to say it. Okay, so that would be the smaller side. So this is the bigger, and this is the smaller. So how do I compare it? KJ or JK, I write it as an inequality. So this is your answer. This is exactly what you would write. You would write JK and compare it to MQ, and you need to fill it in. Are they equal to each other? Is this bigger or is this smaller? Keep it in the same order, okay? If JK is written first, put JK first. If MQ is second, put MQ second. So what's true about KJ or JK? It's larger or greater than MQ, and that would be your answer. It's as simple as that. That's all you have to do is just write that inequality. Let's do another example. All right, here we go. Let's take a look at this last example. The question is a little different than it was before. It says, find the range of possible values for x. So here, this angle right here is 6x plus 15. So what I want to do is I want to find out, when it says the range, remember we did this before, I think it was on the last lesson, we talked about what numbers could it be between, all right? Because there's not just like one answer for x, because you'll see here in a second. But let's just see what we can do here. First of all, how do these triangles relate to each other? Well, I've got one side equal to another side. I've got two unequal sides. Do I have another side? Yeah, I got EH. Remember reflexive property? So I could do this. I could put EH equal to EH. So look what I have. I have two sides of one triangle equaling two sides of another triangle. And I also have the third side is larger or bigger than the third side. Third side of this triangle is bigger than the third side of this triangle. This is that side inequality, or the converse of the hinge. I like this one because it makes a little more sense when I see these sides. Side inequality. Remember, these are not equal to each other. If they were equal to each other, these triangles would be congruent, but they're not. This is bigger than this one right here. So I've got side inequality. What does the side inequality theorem, or the converse of the hinge theorem, what does it tell me? Well, it says that the angle opposite the bigger side, this one right here, is going to be larger or bigger than the angle opposite the shorter side. So that means that this 6x plus 15 has got to be greater than this 65 degrees. So I can actually find one of my values for x. And you're like, well, one of the values, I thought we were only going to get one answer. Nope, there's actually a range of possible values for x between one number and another number. So let's do the math on this very quickly. So I've got 6x, subtract 15 from both sides. That still stays greater, and that would be 50. Divide both sides by 6. And x is, remember, we don't change the inequality. The only time we would change that inequality is if I multiply or divide by a negative number, and I haven't done that here, so I'm just going to keep it like that. So let's reduce this. Let's see, 5 goes, let's see, 5 goes into it. Yeah, they do it one way. No, 5 doesn't go into it. 2 goes both of those, what, 25 over 3 times. And you could just keep it like that. If you really want to change it to a mixed number, I guess that's okay. How many times does 3 go into 24? 8 times with 1 left over. So you could write 8 and a third, or you could just write 25 thirds. It might be easier for us, though, if we change this to a mixed number. It might make a little bit more sense. All right, and you say, okay, well, that wasn't too bad. I kind of get that. I understand, where we get that from. But here's the next part. I bet you would have a hard time doing this on your own if I didn't tell you, or if the book didn't tell you. We have to have a range. All right, so we have to say, does that mean that x could be any number greater than 8 and a third? Well, let's see. We're going to actually have a range of numbers that it can be between. For instance, I mean, can I go to like 1,000,000, okay, or 1,000 or something like that? Well, let's take a look. There's two things that we know about this 6x plus 15. The one thing we know is it's bigger than 65. What I want to find out is what x could possibly be less than. All right, x could possibly be less than. So let's think about these angles inside this triangle. This is the part right here. This next part is the part that's a little bit tricky. But once I show you the little trick, it's not so bad. What do all three of these angles add up to be? They'd have to add up to be 180. So tell me something that this angle right here has to be less than. Well, if all three add up to 180, then this one has to be less than 180 degrees. All right, it's probably something you hadn't even thought about, but that's how we're going to find our range of possible values. So this angle, this 6x plus 15, 6x plus 15, has to be less than 180 degrees. I hope that makes sense to you because all three angles add up to 180. So that means that any one of these angles has to be less than 180 degrees. And now we can actually solve for x here. And then we're going to have a number that x is greater than, and we're going to have a number that x is less than. So let's give that a shot. So we subtract 15 from both sides. We take 6x. We still keep it less than, and that's what, 165, and then we divide that by 6. And if you work that thing out, I'll let you work that thing out. I'm just looking in the book. It's going to be about 27 and a half. All right, the book says 0.5. We'll just use a fraction. So let's take a look at that. So I just want to visualize what we're doing here. So what's the smaller of the two numbers? It's right there. It's 8 and a third. What's the larger of the two numbers? It's 27 and a half. What does that mean? That means x has to be larger than 8 and a half. So any number bigger than 8 and a half, but it can't go forever. It can't go real big. It's got to be less than 27 and a half. So x lies somewhere in between here and here. All right, it can't be equal. It's got to be less than. So how do I write that inequality? Well, this is how I write it. We did an inequality earlier. Watch, x has to be between. This is how I show x is between. X has to be less than 27 and a half, and x has to be greater than 8 and a third. And that is my range of values that my x has to be. It can be any number between 8 and a third and 27 and a half. If I pick a number smaller than 8 and a third, this won't work. Okay, this won't work. If I pick a number bigger than 27 and a half, this won't work either. All right, it can be any number that's in between 8 and a third and 27 and a half. That's a little confusing. And again, where's the confusing part? The confusing part probably is this thing right here, setting that less than 180. But now that you see it, it's something that you got to look for. So when you see a problem like this, you're going to have two, and it asks for the range. This is going to be the first step, just setting that, just finding, what's the relationship. It's opposite the biggest side, so it's got to be bigger than this. So we set it bigger than 65. But then you got to have a second part. What is it less than? Well, it's got to be less than 180. So you set it less than 180, you do your math, and you go on from there. Okay? Well, I hope that helps a little bit, and good luck on this next lesson.